Welcome to Module 7, Lesson 3, Converting Within Measurement Systems. Today we're going to talk about how to use ratio reasoning to convert between measurement units and how to transform units appropriately when multiplying or dividing quantities. All right, so we're going to convert between measurements within the customary system and convert between units within the metric system. Now, I don't expect you to always convert, especially within the metric system, using ratios. However, the idea behind this is to understand how ratios or how measurements are a form of ratios, and especially within the customary system, how you can use a conversion factor to help you convert. Metric systems really are base 10, so you won't use them as much, but it does also work within the metric system. Basically, this more so works within, or is more so used within the customary system. Okay, so here we're going to look at a model using feet and yards, and I'm going to go ahead and give you my dad's silly joke here, and his question is always, well, how many feet are in a yard? Well, it depends on how many children are playing in it. Ha 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 ha. I know it's a silly, stupid joke, but I gotta tell you the dad jokes while I still have them, because my goodness, I tell you, it always makes me look at them and go, you are ridiculous, but they crack me up. So here we go. I have 1 yard giving me 3 feet. So in my model, every time I draw a rectangle for 1 yard, I draw 3 little rectangles within it to represent 3 feet. Okay? So each of these little rectangles here is a foot, and 3 of them will fit inside of a yard. So if I have 2 yards, so 2 of these larger rectangles, that means that I will have 6 of the smaller ones, so I will have 6 feet. If I have 3 of the larger rectangles, I see that I have 9 feet. And I see that if I have 4 yards, I will have 12 of these smaller rectangles, and I have 12 feet. Okay. If I write these as ratios, I see that if I have 6 feet for every 2 yards, if I reduce that to its unit rate, I find that I get 3 feet per yard. If I look at the 9 feet per 3 yards, so again, 9 feet for 3 yards, right here is what I'm looking at, 9 feet for 3 yards, or for every 3 yards. If I reduce that to its unit rate, I do come down to 3 feet per yard. And again, if I look at 12 feet for every 4 yards, or 12 feet per 4 yards, and again, 12 feet, and that gave me 4 yards. If I reduce it yet again, I find that have the same unit rate. So every time I'm finding that since 1 yard is equal to 3 feet, the ratio of feet to yards in any measurement is always 3 to 1. Okay, so this means any ratio forming a proportion with 3 to 1 can represent the ratio of feet to yards. So 3 to 1 is equal to 12 to 4, so 12 feet is equal to 4 yards. 3 to 1 is equal to 54 to 18, so that tells me that 54, since 54 represents the number of feet, I know 54 feet is equal to 18 yards. All right, so basically, as long as my ratio reduces to a unit, or my rate reduces to a unit rate of 3 to 1, and it reduces to that unit rate of 3 feet to 1 yard, I know that it is equivalent, so it is accurate in terms of my conversion of feet to yards. All right, so how would I draw a model to show the relationship between feet and inches? Well, first I have to know the conversion from feet to inches. So I need to know that on a ruler, so I can pull a ruler up here. So pull up my math tools. And if I look at a math tool, okay, so on a ruler, I know that this ruler gives me half a foot. And I'm actually going to put my inches on top. So this is half of a foot. So half of a foot is 6 inches, so a full foot is going to be 12 inches. All right, so 12 inches is going to equal 1 foot. So 12 inches equals 1 foot. So in that case, every time that I draw one large rectangle to represent my foot, so if this represents 1 foot, I would have to draw 12 smaller rectangles to represent my inches. Now I want to do them in different colors so that way, there we go, so 1, and each of those would represent an inch. So 1, 2, and maybe I actually should outline those differently so that way you can see that they are actually different rectangles. So there's 1, and I'm going to do my best here to make these even. So there's 1, 2, 3, 4. Okay, and just to make this go a little bit faster. Okay, there's another 4, so now I have 8. Okay, and then now I'm going to have too many though because I copied another 8. So there's 16, so that's few too many. So, all right. So here, now I know that I have 12 smaller inches. So each of those represents an inch. So since each of those represents an inch, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now each of those represents an inch. This larger one is going to be a foot. So now each smaller rectangle represents an inch, and then those 12 inches fit inside the one larger rectangle, which is 1 foot. In words, we can draw one large rectangle to represent a foot. Below that, draw 12 smaller rectangles to represent the number of inches inside of 1 foot. Okay, so as long as you know your conversion, basically you have to know your larger unit is going to be your 1 rectangle, and then your smaller rectangles are going to be your smaller unit. And then you're going to draw the number of smaller units underneath to fit inside of that larger unit. So again, like if I were doing the number of gallon or the number of quarts in a gallon, I could do 4 quarts. So here's 1, and I'm going to do 4. So 1, 2, and I want 4. So I'm just going to copy and paste another 2. So here's 4. Okay, so since there's 4, I know 4 of these make 1 gallon. So now I'm going to make my larger rectangle. So 4 of these would fit into 1. And I should have done that the first time. I should have made maybe my smaller rectangles first and then made that fit into my larger rectangle, since it's easier to make these first to try and make them the same size. Just a thought. All right. So here we go. Let's start doing this in terms of your conversions. Now above this you have all of your conversions. I didn't put this in my video because you'll have it for you. You'll have it as something that you can access during your lesson. Okay, but you know that for ounces, 16 ounces equals 1 pound. All right, so when you're writing your proportion, you can write 16 ounces over 1 pound, and you can set that up equal to your problem. So in this case, we have a 3-pound human brain. So if you have a 3-pound human brain and you want to know how many ounces that is, so we have our 3-pound human brain, and we're setting it up in a proportion. We have to remember that pounds has to go across from pounds, and ounces has to go across from ounces. So we're going to put X on top. All right. So now I'm going to use equivalent ratios to figure out my answer. So in this case, I know that to go from 1 pound to 3 pounds, I multiply by 3. And we know that our rule is what I do to the bottom, I have to do to the top. So since I multiplied by 1 to get to 3, I have to multiply 16 by 3. And when I do 16 times 3, I get 48. So the equivalency is that if 1 pound is equal to 3 pounds, then 16 ounces is going to be equal to 48 ounces. So 3 pounds is going to be equal to 48 ounces. So that 3-pound human brain that you are carrying around in your noggin all day is going to weigh 48 ounces. Right? So we set it up again as a proportion. We say 16, our conversion factor is that 16 ounces is equal to a pound. So 16 over 1 is equal to X, because we don't know the ounces, over 3. And then we use our equivalent ratios to find the answer. All right, so now we're going to take a look at this in terms of the metric system. Again, you have your conversion factors above. So we have a moderate amount of daily sodium, sodium being salt. So we have our little salt shakers here. And we are looking at milligrams. So we have 2,000 milligrams. And we want to know what that mass is in grams. Right, so 2,000 milligrams, and we want to know what is that mass in grams. So again, we're going to go ahead and write a proportion. So we're going to write the conversion factor first, because we write what we absolutely know first. Well, I know, especially like just in case I don't have those conversion factors, remember our little silly sentence, King Henry died by drinking chunky milk. Okay, so I know that my base is grams. So by drinking chunky milk, so that's 3 spaces away. So that base is grams. So 1 gram is equal to 1,000 milligrams. So 1 gram is equal to 1,000 milligrams. And then I want to know how many grams are going to be in 2,000 milligrams. So I put my X above 2,000 because X is what I don't know and 2,000 is what I do know. X is my grams because that's what I'm looking for, so it goes across from 1. 2,000 is what I do know, and it goes across from 1,000 because they're both milligrams, so my proportion is set up correctly. Okay. Once again, I'm going to use equivalent ratios. I know that to go from 1,000 to 2,000, I multiplied by 2. What I do to the bottom, I have to do to the top. Right, Xavier? And I know that 1 times 2 is 2. So then I know that 2,000 milligrams is going to be equal to 2 grams based on my conversion factor. Right, so what I want you to do, you're going to use your ride, and you are going to do this your term problem using equivalent ratios. Okay, so right now we're using equivalent ratios. We're not using the conversion factor as a multiplication step just yet. Okay, we're learning this in 2 different parts right now. We're learning 2 separate ways to do this. Right now I want you doing it as equivalent ratios. And then when you come back, we'll check your answer. All right, so you should have found that the height of the doorway in inches was 72 inches tall. Now this was a little different because you had to do 3 conversions. So you should have found that the doorway was 2 yards tall. So 2 and yards were important. And you should have been highlighting the question, what was the height of the doorway in inches? And I would have underlined the word inches because it is important to note that inches is what we're converting to. So we're trying to go from yards to inches. So yards to inches. Well, if you look at our conversions, we don't really have a conversion from yards to inches. Okay, but we do know that we can go from yards to feet. Okay, so that's the connecting piece. And then we can go from feet to inches. I don't know why I put another line because we don't have to go past inches. Okay, so here what we did was we said, all right, we have 1 yard for every 3 feet and we have 2 yards, so we're going to convert those 2 yards to feet. To go from 1 yard to 2 yards, I multiply by 2, so I'm also going to double the feet. Okay, so that gave me 6 feet. I know then that every 1 foot gives me 12 inches, so to go from 1 foot to 6 feet, because that's how many feet I had in those 2 yards. Okay, so I went from 2 yards to feet, because in 2 yards there are 6 feet. And then in those 6 feet, I wanted to find out how many inches there were. So I went from 6 feet. I used the conversion factor that in 1 foot there are 12 inches. To go from 1 to 6, I multiplied by 6. What I do to the top, I do to the bottom. So 12 times 6 is 72. And I got 72 inches. So I know that there are 72 inches in 2 yards. So therefore, my doorway was 72 inches tall. So sometimes it's not always going to be a straightforward conversion. Sometimes we're going to have to take multiple steps to get to our answer. All right, so now we're actually going to use our conversion factor as a multiplication problem. So we're not going to set it up as a proportion. We're going to set it up as a straight up multiplication problem. So we're going to set it up more so as a fraction instead of using it as a ratio. All right, so now I have Elena who wants to buy 2 gallons of milk. And she can only find them in quart containers, so that's kind of a problem if you don't understand conversions. And she needs to figure out how many she needs. So the question is, how many quarts does she need? I would underline the word quarts because it's important to know that she has to figure it out in quarts. I would underline gallons because that's how much she needs, and she needs 2 of them. So she needs 2 gallons, but she can only find quarts. So first we're going to find our conversion factor. Our conversion factor in this case, under our cow here, because you know he produces milk, is that 4 quarts gives us 1 gallon. So the conversion factor, we're going to set it up then in ratio form, or we're going to set it up as a ratio in fraction form, I should say, is that 4 quarts gives us a gallon. And you're always going to put the unit that you're trying to get to on top. So in this case, I'm trying to get to a quart. So since I'm trying to get to a quart, it's on top. So I'm given gallons, that goes on bottom. I'm trying to get to quarts, so that goes on top. All right, so I have 4 quarts per 1 gallon. Okay, so 4 quarts would give me 1 gallon. Now I'm actually going to set this up as a multiplication problem. Okay, so in this case, I have 4 quarts and I'm going to multiply that by the 2 gallons that Elena needs. So here's my multiplication problem. I have my conversion factor. So again, this is my actual conversion factor, the 4 quarts per 1 gallon. Is my conversion factor. And the 2 gallons is what Elena needs. So you take your conversion factor and multiply it by what you need or have, okay? And it's going to equal what you're trying to get to, or it's going to equal the next piece of what you need to get to. But now what's going to happen is when I multiply, I have 4 quarts over a gallon times 2 gallons. And remember, since I'm multiplying fractions, that whole number has to go over 1. 1 is not going to have a label though, okay? It's just over 1 because it has to be made into an improper fraction. Gallons and gallons cancel each other out because of the fact that they are, one is on top and one is on bottom. And so you're left with the label of quarts. So I have 4 times 2, and in this case, my answer then would be 8, and the only label I'm left with is quarts. So therefore, Elena would be looking for 4 quarts of milk in order to buy her 2 gallons. All right, so let's go ahead and give you a shot to try this on your own, and you're going to try this with the metric system. Now with the metric system, it's a little bit nicer, and remember you have your stairs that you can use. I'm going to attempt to draw this, and it's going to look horrible, okay, but remember it's King Henry died by drinking chunky milk, where it's King is your kilo, Henry, hecto, deca, so that's your big D, by, so that's your base, so your gram, liter, and gram, liter, what am I forgetting here? It'll come to me in a minute. And then by drinking, so this is your deci, centi, and milli. Okay, so every time you move, this is a multiple of 10. So in this case, since I'm going from centimeters to meters, I'm going to help you out here. This would be times 10 because I'm going up, times 10 since I'm going up. So times 10 would be times 100. Okay, so what that tells me is 1 meter equals 100 centimeters. So liters, meters, grams. I told you it would come to me. All right, so go ahead. Here's your conversion factor. Do your ride, and then go ahead and find your answer, and when you come back, we'll check it out. All right, so in this case, again, you should have found that your conversion factor was 1 meter equals 100 centimeters. So then when you multiplied that, you would have gotten that since you're going from centimeters, again, what you want goes on top and what you have goes on bottom. So now here, you would have ended up dividing because of the fact that 250 would have been over 100. So you would have done 250 divided by 100 because of how it works out. So 1/100th times 250 would have been set up like this, 1 over 100 times 250 over 1 equals 250 over 100 equals 2 5/10 centimeters. Or I'm sorry, not centimeters, meters. Okay, so the oak tree is 2 5/10 meters tall. Okay, so when it comes to these pieces where the conversion looks a little bit different, where you end up dividing, we're going to get more practice with this. So don't get discouraged if you're looking at this and it's a little bit more challenging. Okay, we are going to get more practice with it. We are going to take a couple of days on this. You are going to get some practice within your guided practice. Set it up doing your fraction multiplication and your fraction setup because it's going to help you in the long run. All right, you have your guided practice problems here. All right, these two are, so 1 and 2 are going to be in your guided practice. And as always, if you have any questions, please be sure to write them down or email me so we can go over them in class.